So here's our first example using Bayes' theorem to calculate an a posteriori probability. I'm going to give you a minute to read this. Okay, so I've defined here A to be the event that the message is in spam, and B is the event that the message contains the phrase, "I saw it on Oprah." How do I know that we should be using Bayes' theorem instead of what we previously learned about conditional probabilities with a priori probabilities? Well, if that was the case, then we would not have this information. Probability of B given A. Do we have the probability of the message containing, "I saw it on Oprah," and it's in spam? And we do. We have that there's a 30% probability that the email will contain the phrase, "I saw it on Oprah," and it is in spam. Okay, so one piece of information that is missing is the probability of a complement, the probability that the email is not in spam. That would be 100% minus 80%, 20%, so 0.02, sorry, 0.2 right here. Notice that in your numerator and denominator, even if there were more things involved in the partitioning of the sample space, that one of your terms in the denominator is always going to match up with what we have in the numerator. You could, with proper parentheses around things, parentheses around the multiplication in the numerator, and then, well, maybe that's not needed, but definitely around the addition that you have in the denominator. You could type this in all at once, but if you break it down step by step, then multiplying 0.8 by 0.3, and then 0.2 by 0.02. Let's check this out, by the way. Give me a moment. Just had to fire up my virtual calculator there. Okay, so 0.8 times 0.3, that should be 0.24. Yep. In the denominator, we're going to be adding to that 0.2 times 0.02, which should be 0.004. Oh, forgot my decimal point there. 0.2 times 0.02. So if we're adding on another 0.004, I think we're going to get 0.244 in the denominator. Yep. Okay. So dividing the numerator by the denominator, that's what I had typed up previously. So let's see here. Rounding that to 4 places, and then expressing it as a percent, since all the information was originally given in percents. 4 places as a pure decimal would be to the 100th of a percent, 98.36% chance that if it contains the phrase, "I saw it on Oprah," then that, 98.36% chance that the message is in spam, given that it contains that phrase. Okay, about to do another example where, again, the sample space is partitioned into two.